So we are going to go through X2, practice exam number 2, questions 1 to 3 that are related to entropy and information gain and stuff. So the first question is asking about there is a bag containing 20 red or green balls, and we want to find the composition that maximizes the entropy. So it's a binary variable, either green or red, and we know how to plot this based on the probability it being red or being green. The entropy function looks like this, and it's maximized when the probability is a half. So the intuition behind this is entropy measures the amount of information contained in the realization of a random variable. So here, if we have like 100% red ball, then actually drawing a ball, knowing that it's red, doesn't get you any information. However, if it's 10 red balls and 10 green balls, then actually drawing a ball gives you a lot of information about the color of the ball. Because if you don't draw it, then you are really uncertain. So when you draw it, you gain a lot of information. So that's why, intuitively, why it is maximized at a half. So in particular here, as I said, is 10 and 10. And the other version of the question asks about when it's minimized. So you can guess it's either here or here. So either 0 and 20 or 20 and 0. Because again, all of the balls are red or green, so drawing one doesn't give you any information. Again, in the minimum case is this, in the maximum case is that. The next question is not really a good question, because the way I randomly generate this is kind of not good, because I randomly generated a number first, and I wanted them to create zero information gain, but it turns out due to some kind of random rounding error, it's not always zero. So like a good version of the question should say that the information gain is exactly zero. So we will solve this problem assuming it's exactly zero. And in any case, the information gain is exactly zero if two variables are independent. So I think there is a question from the homework that asks about the independent question. Basically, you have two missing entries, and you are asked to figure out what are those drawing probabilities so that the variables are independent. But in any case, here we have red and black, and talk is yes and no. So the probability of yes and red is 22 over 46. There are 46 in total. And we're going to call this X. So red and no is X over 46. And then yes and black is the total 64 minus 26 minus 7 minus X, so 35 minus X. And at the end, 7 over 64. And the question is, well, when is this thing independent? So you can pick any entry and show independence. For example, you can pick this entry and say that the probability of Ry is the same as probability of R multiplied by probability Y. Again, that's the definition of independence. So if you write it that way, then it's basically 22 should be equal to the probability of R, which is the sum of these two, 22 plus X, times the probability of Y, which is the sum of these two. So 22 plus 35 minus X divided by 64. So now you have an expression like this. You can just solve for x. So again, there is that kind of non-integer problem. So the question again is not great. When you solve this, you may not get an integer. But well, in theory, if I made the numbers so well that it is actually exactly 0, then this should work out. Okay, so that's question 2. And question 3 is just a computation question, so you need to know the formula. The formula of conditional entropy is just probability of, I think, A. There should be a minus sign in front. Sum over A and sum over B, probability of B given A, log base 2, probability of B given A. So knowing that, you need to just compute the probabilities, and these probabilities can be estimated using MLE. So in the question, I should state we're using MLE with no smoothing, or no regularization. But well, let's just assume that. So probability of A is true is, there are 8, there are 2 of them that are true, so it's 2 over 8, and A is false is the rest, 6 over 8. Excuse me. Probability of B is true given A is true. B is true given A is true, so we focus on these two, and there's one of them, so 1 over 2, and probability of B is false given A is true is just 1 minus that. Probability of B is true given A is false is something over 6. How many? So among these ones, the number of truths, 1, 2, 3, 4, 4 over 6, and B is false given A is false is 2 over 6. So okay, so now you get all the numbers. You just write down like a large expression. Sum over A means sum over A is true and A is false, and sum over B means sum over B is true and false. So there are, I think there are 4 terms, I mean a term of 4 terms in total, and just having these probabilities just substituting into the formula, and you'll get the answer. Oh, and also remember this is log base 2, so you can do log base E divided by log base E of 2. So again, everything else is just substituting these numbers into this sum.